So I'm going to give a brief overview of, the program here, what we're doing, and then Ora Lee and Dave Fleischer will follow up with some details to get, some specific thrusts to give you, more context of how we're approaching this. And then Bill Salas will introduce the DNDC model. So next slide, please. So I just want to make the point here, what are the decision support tools, right? Decision support tools is data, models, and a user interface, right? So that's what our team is working on, is all of those things, right? The data and the models that we're working with, that includes expert opinion, empirical and process-based models, and in some cases, we're doing some hybrid modeling with machine learning and process-based models. So I just wanted to define that so everybody's clear what we're talking about here. And the goal of these decision systems and these models as a whole is, first, certainly foremost, to ask those what if questions for the researcher, right? We increase cover crop adoption and performance by X amount in the Chesapeake Bay. How much does that reduce nitrogen loading and improve water quality and such, right? So those are just examples of how we might, ask those what if questions, and doing that at the field all the way up to the landscape level. But we certainly want our tools to be directly going through the typical technology transfer pathways of, NRCS technical staff, county agents, private consultants, and for those farmers who want to directly interface with our tools. But we also want these tools to be informing policy, right? That's why there's been active communication with NRCS, for example, and even RMA so when they're making recommendation systems around cost share or crop insurance, that they have our data and our tools to inform those programs. So that's kind of the scope and the scale here. Next slide, please. So I'm going to just walk through this. There's a lot going on here, but I just want to give a quick review of what we're doing here and kind of go item by item, and then let Ora Lee give an example of an individual slice of this to show you the approach. So going through our different models, most of you have heard about this cover crop decomposition and nutrient release models that we've been working with, that Miguel Cabrera at University of Georgia has been leading that effort. And we've been working for years to regionalize that tool across the East Coast. And we have a lot of data to regionalize that. Resham Thapa, that was his PhD, working across the network, and now we're going national to really build out how that climate and soil and cover crop quality drive decay and nutrient release. We've got individual plant level models around corn, soybeans, cotton, and cereal rye simulation models. All these are very process-based models developed by the Beltsville team. Dennis Timland and Dave Fleischer are really kind of the leaders of that effort. And so they're working collectively to take individual plant-based models all the way up to the landscape, and that'll be described in a second. Bill Salas will introduce the DNDC model and what we're doing there with field scale level estimations of greenhouse gas and carbon flows. We are doing a lot, obviously, on water cycling, right? We have a whole water sensor network, so we're doing a lot with Ora Lee taking the lead on water cycling, and so she's going to take a deeper dive on that. So I don't want to steal any of her thunder. And then, we have a lot of AI applications all around these monitoring systems, right? In our IoT systems, right? From modeling water dynamics, nitrogen dynamics, and even like targeting where we would take a sample. And I'll describe that decision tool in a second, but actually like targeted cover crop biomass sampling is another AI application with our sensing team. And then yield stability and profitability models are obviously going to come out of this. I want to highlight these model and DST drivers. These are data that obviously is coming from our field inputs, like the on-farm CE1 and 2. But as you recall in this grant, we also are wanting to do some archival, collection of these historical data sets. So we will be coming on some standard, database formats to kind of ingest where we can historical cover crop performance data. So stay tuned for that as we mature in the program. So these are destructive samples and sensing technology that will be used in that effort. But we are also developing adaptive management modules. So this is where, there is a lot of weather data that's publicly available through, NOAA, MRMS, but these are not machine readable and usable for our modeling systems, right? A lot of the private sector has developed ways to build APIs and aggregate that data and use that in their tools. But there really isn't publicly available tools, surprisingly enough, to access this. So we've been really busy for the last year or two now developing APIs around these data so they can feed right into our models and our tools. And really pleased to see the work that Rick and the Georgia group and others developed around the weather app. Huge product for us. So, as we build interfaces around these models, they become decision support tools, right? And here's just a suite of the tools that we're targeting. I put the ones in red as just to show these are tools that we are interfacing with as cover crop council members and as PSA members, but are not direct deliverables in this grant. So we are focused around developing cover crop spatial variance mapping and sampling tools. So being able to actually develop spatial maps of cover crop performance, use that to drive management, but also to improve our estimation of performance. We're developing spatial variance maps with satellite imagery to be able to make recommendation systems for growers where to sample like high and low points of the field to have a minimal ask of the grower or the researcher so that we can better attribute the performance of that cover crop across the field. We are developing adaptive nitrogen calculator, as I described from the models above. And so that's a decision tool that's already live in Georgia, and we'll be rapidly developing interface and around it to go national in the near future. I mentioned a little bit about the water calculator. That's a project that Aurelie is heading up that we just got some funding around that we're excited about with some of our private on-farm network partners. Some of the historical tools that we started with the councils like species selection, economics, and seeding rate calculators, those are ongoing efforts. It's not really funded in this project per se, except there is some resources around the economic calculator. So really excited to work with the economist team. Rob Myers is heading that group up to flesh out that economic calculator. WeedSim is a weed decision support tool that was developed by Mutu and Jason Norsworthy years ago. The Grow team is continuously regionalizing that product with resources from that network, and this grant also gave that project a big shot in the arm to continue to regionalize that IWM tool. We will have tools that interface with these recommendation systems around cover crop growth and development and forming kind of management decision around how to estimate what that performance will be. And I mentioned earlier, obviously, about what we're using with satellite imagery, but there's a range of remote sensing technologies we're using to be able to develop geospatial mapping tools so that the end goal of this is that when farmers are making precision management, in their systems around inputs like fertilizer, herbicides, crop populations, that it's interfacing with geospatial maps of cover crops. So next slide, please. All right, so I'm going to hand this over now to Aurelie, who what she's going to do is take a slice of the many different products I described and then give you an example of the water perspective and how we're approaching that. Aurelie?
Oh, thank you so much, Stephen. Good morning, everyone. So like Stephen said, we are taking a very similar approach to modeling, whether we're working with the water sensor data or with the biomass data or even the yield data. And I wanted to show you a little bit what we are doing with the water data. So just to give you an idea of the work we have conducted so far, we started collecting data in 2017. So to date, we have 4 years of data. We have worked with more than 70 producers and collected data in more than 200 site years across 7 states. So the network is expanding next year, and we're going to continue the data collection and continue to feed the data into our modeling effort. So in every location, we established a strip of bare soil in the cover crop field, creating 2 adjacent treatments. And in each in each iter, we have 2 treatments and 2 replications starting next year. And we have been collecting the same data in each location. If you want to move to the next slide. Okay, so we have collected data about to describe the management practices that each farmer selected in each location. So we basically allowed the grower to use any preferred management practices So we asked them about, the cover crops species mix that they wanted to plant, and the planting method, planting dates, the termination method, the termination date, and their nitrogen management strategy. Then we used the system that Alondra and Harry built to measure volumetric soil water content throughout the cash crop growing season in both treatment and within the soil profile. We also collected data about cover crop quality and quantity, so fresh cover crop biomass as well as decomposing biomass, like Resham talked about earlier. We collected soil texture data at the location of the sensor to have an idea of the local soil properties in the field and being able to capture spatial variability. And we gathered weather data from the Federal Weather Data Repository. So we centralize all of that data into a SQL database, and we use that database to support the modeling effort since then. If you want to move to the next slide. Okay, so the first step of my analysis with sensor data, the first thing I needed to do was to clean the data and remove noise and convert the individual volumetric water content data into a cumulative depth of water in the field. And when I have done that for every site, then I was able to kind of look at what I had before I started to build like my models. So in some of the sites, like this site, I was in North Carolina in 2017, I saw that cover crop had a very positive impact on soil water reserve, because throughout the whole growing season, we had like 4 to 8 centimeters of additional water in the soil profile due to the cover crop. If you want to move to the next slide. Okay, but so in some of the other sites, we didn't have such an obvious and consistent effect throughout the growing season. And sometimes the cover, like you had more water in the cover crop treatment, but some of the time you had less water in the cover crop treatment. So next slide. Okay, so the result from just looking at the raw data without doing any modeling or anything clearly supported the assumption we had that the cover crop effect on soil water dynamics was site-specific and depended on local soil, weather, and management. So the first step in the analysis was to continue to prepare the data and use various statistical and machine learning techniques to try to identify and quantify the site-specific drivers of the cover crop effect on soil water dynamics, so for me, but also nitrogen cycling and cash crop yield for like the rest of the modeling team. So the analysis for the soil water dynamics is ongoing, and my objective is to draw conclusion from the data, looking not at one best model, but as a convergence of the many different models I want to build. At the end, I should be able to make inference about which driver, which are the site-specific driver of cover crop effect. So we need to add that cover crop management, soil and weather condition across the network were very diversified, and we expect the results to be applicable to a wide range of growing conditions that we observed, in the southeastern US so far, but then in the Midwest when we start integrating that data. Next. So when that step will be done, we will start using the PSA on-farm data and try to simulate that observed data using the mechanistic models that Stephen was talking about earlier. So we will use the on-farm, like the soil and management and weather data from the on-farm network to set input and boundary conditions to those models. And then we will try to compare the output of those simulations to the observed data that we have in the field. We will compute some residual analysis and to make sure that we don't have any systematic bias or error in like the output from the model. And we will try, we will have, so you can keep going. Okay, and then we will have a round of like iteration and improvement to try to maximize the process-based model performance. And once we have established that the results from the process-based model are robust, we will try to leverage the result from our whole entire modeling effort into 2 major applications. If you want one last time. To move to the next slide. Okay, so the first thing we want to do is to build a user interface around all this model to create a decision support tool that will deliver site-specific recommendation to the growers across the US. So the decision support tool will be designed to serve any grower independently of their level of expertise with cover crops. So it will serve non-cover croppers, people that are just starting 1 or 3 years experience, and people that have been like long-time cover croppers. And you will have, our tool will have like 3 major functionalities. So first, we want the tool to help grower understand how like the impact of their cover crop management strategy on soil water dynamics in their field. And to do that, we are going to allow them to estimate the impact of their management strategy and other possible management strategies in their field, like by asking them for their local growing condition. Then we will use our decision support tool to provide recommendations to growers and to maximize the effect of cover crop on soil water dynamics in their field. So we will base our recommendation on the level of expertise of a grower, their present cover crop management strategy, and the soil variability they have across the farm to try to help them benefit from cover crops over time without forcing them to drastically change their management strategy, which would increase the risk associated with cover crop adoption. So we're going to try to limit that risk by providing them, with a case-by-case recommendation. And eventually, we're going to use our decision support tool to simulate the impact of different cover crop management strategy under present, but also future climate condition to try to make growers and stakeholders understand the importance of starting the process of improving their management strategy with cover crop today to benefit from more sustainable and resilient practices in the future. And next. So that's for the decision support tool site-specific application. Then we are going to try to scale up our analysis with landscape modeling or geospatial modeling to try to evaluate the impact of existing and new management strategies in present and future climate conditions across a regional scale rather than within the field. And I will let David Fletcher talk more about that part of the project.
Great, thank you. Can everybody hear me?
Yes.
Okay, good. I was having problems earlier with my mic. So I don't have my slides made in here, but I can talk. I think I only have like 2 minutes. So, here it is. So Arlie really did a great segue into this, and I just want to emphasize for the common experiments, a lot of that data we're going to be using to kind of ground truth our mechanistic models. So there's really a strong connection between our groups. So very quickly here, because the models are mechanistic, we can use them to not just make site-specific recommendations, but we can actually forecast into kind of this arena called what-if type questions. And so if you see on the slide here, there's a thing that says scenarios under there. And so for cover crop management, we want to look at, excuse me, things like planting density, effects of nitrogen fertilization rate, planting and termination dates, and the effects that climate scenarios would have on looking at both cover crop and then cash crop responses at specific site locations throughout the region of interest. And the diagram I show here is a little bit older. It's from a different project I have. It's the same concept where we're going to take all kinds of digitized information, and Arlie and Stephen talked about some of the apps that have been developed, whether it's for soil or climate or how land is currently being used in different farms. And on these like slices of a cake that kind of have common themes, we do these modeling units. And so we apply the climate data and we look at these different kind of what-if scenarios. We link them with our crop and cover crop and the work that Russian is doing with residue decomposition. And we simulate things like yield and water and nitrogen use and also soil organic carbon increases over time because of cover crop management. And ultimately we want to look at cash crop yield or the performance as well. The idea being we can go back and generate these sort of maps. I'll show that on the next slide. And try to identify these best management practices that work both for current climate, but also how they may change in future climates. Next slide. And this is, again, just the last slide. And the picture is always worth 1,000 words. And again, this is from a different project, but it's the same concept where we scale up from these sort of site-specific areas. We scale up, and this project was scaled up to a county basis through the Northeast Eastern Seaboard. And we're looking at effects of different climate change impacts and adaptation strategies like irrigation, rainfall, planting dates, and how it would affect silage production. So we plan on generating these different kinds of maps for these different kind of what-if scenarios we're talking about with the cover crops. And from those maps, we'll then be able to identify kind of these optimal or best, sorry, of course my phone rings right now. best management practices for these different scenarios. And I think I'll stop there.